Hello everyone. So I've been getting a lot of emails on Schoology about certain questions that are asking you to graph sine or cosine on this weekend's quiz. And first of all, I apologize for not being in yesterday. I was feeling a little under the weather, and hopefully you cannot tell so much by my voice, but I decided to make a quick video, hopefully explaining how to go about solving these types of problems. One of the main, or one of the common themes that I'm seeing on these emails that I'm getting from a lot of you is you're quickly wanting to just graph sine and cosine right away, but without doing any work, and you're kind of just looking at your answer choices and trying to use some technique of process of elimination to try and figure out what your answer is going to be, without really, again, working out the problem. And what I mean by that is, here's a problem that I'm just taking from the quiz. You may get this problem, you may not even get this problem, but it seems that some of you are just looking at this and you're seeing like, oh, I have to graph sine, and we know that the graph of sine, oops, let me erase that really quick and get a better pen. We know that the graph of sine, again, just looks something like this. This is the general shape of sine. It goes from 0 to 2 pi, and it just does something like that. And so I noticed that a lot of you are just looking at that idea, and you're seeing, oh, I have to graph sine, and so you're looking at all your answer choices here, and you're seeing that, look, this one right here, let me circle it, this one right here doesn't look like that shape, and so you're saying that's not the answer. And you're saying, okay, well, this one kind of looks like that shape, so maybe that's the answer. And then you're saying, okay, this one doesn't look anything like it. And then you look at answer choice D, and you're saying, okay, well, this one's familiar, but this one's going down first, and then up, and then down, so we know it's not this one. And a lot of you are just tending to lean towards this answer right here. But it turns out this answer B is the incorrect answer. In fact, if we look at the key, so if we look at the answer key is actually telling us that the answer is C. So here's my answer key for that one. And so if you look at C, you might be thinking, well, how is the answer C? When this looks like a cosine or maybe a negative sine function. So I'm going to show you just how to work these problems out, again, without just diving into the problem and saying, or using process of elimination and all that stuff. So we're going to go through this step by step. You can fast forward this video again over the things that you already know, but if you want to just sit tight and watch how this problem evolves, that might be very, very beneficial for you, especially when working on your own problem. So again, the first thing that we're going to find, just the way we did in class, is the amplitude. Okay, so the amplitude here, hopefully it's very easy to tell, it's just going to be 1/3. The next thing that we're going to look at is the period. So again, the period, the formula here is just 2 pi divided by b, and again, RB is this value right there, which is 2. So this is just going to turn into 2 pi over 2, and again, the 2's divide out, and we're left with pi there. Okay, so the next thing that we can go ahead and find that might be very easy for us to determine is our vertical shift. And so the vertical shift again comes from this value right here that I'm circling in green. And that's just going to be 3, and because it's a positive 3, it means that we're going to go 3 up. And then our increment, this is how we're going to increase our intervals, or this is how our steps are going to increase our step size. But the increment here, again, the formula is just your period divided by 4. And so let me go to move this wheel out of the way. So the period, again, our period was pi, so this is going to be pi over 4. So this means we're going to be increasing each step by pi over 4. Now the only thing that we need to figure out is our horizontal shift. And so the horizontal shift, or our phase shift, as we called it in class, again, we're just going to solve this inequality here. We have 0, and again, the standard sine function is between 0 and 2 pi, that's 1 full period. But our argument for this problem, our argument is this 2x minus pi. So that's going to go here, 2x minus pi. And now the problem just becomes solving for x here, or getting x alone in the middle. So what I'm going to go ahead and do again is just add pi to every single side here. So plus pi. Again, that's going to go ahead and cancel this out. 0 plus pi is just pi. And it looks like we're going to be left with just 2x in the middle. And then here we have 3 pi. Okay, so then I divide everything by 2, and it looks like we're going to have, let's see, pi divided by 2. Once I divide the middle part by 2, I'm just left with x. And then 3 pi divided by 2 is just going to look like this. So here we can get our phase shift, or the horizontal shift. That means instead of starting at 0, remember the original graph, when there's no shifting going on, starts at 0. But now we're going to start at pi over 2. So we're actually going to shift pi over 2 to the right. And again, instead of ending at 2 pi, that was the original ending point, we're now going to end at 3 pi over 2. So this right here is the end. And so we have everything that we need to go ahead and put this graph together. And that's what I'm going to go ahead and do next. So let me scroll down. Again, I'm going to ignore my answer choices here for a moment. And I'm going to try and squeeze my graph in here. Now, if I go back up really quick, I know that my start is pi over 2 and my ending is 3 pi over 2. So I'm going to start by drawing the x-axis. So again, here's my x-axis, and maybe I'm just over-exaggerating this line a little bit, but that's fine. And I'm just going to say that, look, our starting point is pi over 2. And what I have to do is, again, add my increment over and over and over again. So just remember that the increment here was pi over 4. So that means I got to add pi over 4 each time. So here's what it's going to look like. I'm going to add plus pi over 4. And so here's my next spot. And then I'm going to add again plus pi over 4. And then here's my next spot. And then I'm going to add pi over 4 again. And then here's my next spot. And then I'm going to add again one more time plus pi over 4. And I should be, by the time I get there, I should be at the ending point, which was 3 pi over 2. Now here, pi over 2 plus pi over 4, I'll let you work this out on the side, but I've already done the calculation here. If you just add these fractions up, it looks like you're going to get 3 pi over 4. Here, if I add another pi over 4, you're going to get 4 pi over 4. And now 4 pi over 4 is really just pi, so I'm just going to put in little asterisks, or pi if you want to write it as pi. In fact, it might be better to write it as pi, and you'll see why in just a bit. Then if I add another pi over 4, well, 4 pi over 4 plus another pi over 4 is 5 pi over 4. And then finally, if we add another pi over 4, we get to 6 pi over 4. But if you think about 6 pi, and I'll do that here in the side really quick, 6 pi over 4, if I divide the top by 2, that's really a 3. And if I divide the bottom by 2, that's really a 2. And notice that's exactly what we have right here. So everything worked out pretty good as far as our interval is concerned. In fact, I'm going to erase this 4 pi over 4 here, and I'm just going to put that with pi. And you'll see why towards the end in just a bit. Now, I could keep going if I wanted to. I could go ahead and just add another pi over 4, and then I'd be right there, and then I could add another pi over 4, and I could keep this going for as long as I wanted to. But I really don't need to. In fact, I could even do the opposite, and maybe I wanted to go backwards. If I wanted to go backwards, I would have to take away pi over 4. And this is interesting. If I take away pi over 4, then if I subtract this, now I'm at pi over 4. And if I go back again, another pi over 4. So pi over 4 minus pi over 4, that's just going to give us 0. And so I could literally just make the y-axis right here going through 0. And again, we can keep going in this direction if we wanted to keep taking away pi over 4. So again, that's kind of the setup there that I'm going to work with. This is my graph here. And now I'm going to go ahead and plot some numbers on the y-axis. So let's just say this is 1. Let's say this is 2. Let's go with 3. And I guess that's enough space there. I ran out of space. But let's do -1, -2, and -3. And what I'm going to do is break this graph down into a couple of pieces here. So the first piece I'm going to graph is in green. And now if we go back to our information up here, the original graph starts at 0, and I got to remember that I'm graphing sine here. So I'm graphing sine. And so if I'm graphing sine, we got to remember that the original graph of sine starts at 0. But instead of starting at 0, we're shifting over to pi over 2. So instead of starting here, we're now going to shift over to pi over 2. So it's going to look something like this. So what I'm trying to say is that instead of starting here at 0, I'm shifting over to pi over 2. This was our starting point. So there's my first point there. Now just keep in mind, if we were graphing cosine, then instead of starting at 0, we'd be starting at 1, but we'd still be at pi over 2. So this is, I'm making the dot here if it was cosine. But since we're not working with cosine, we're working with sine, it would be at 0, so let me erase that dot there. Now, our amplitude, we said the amplitude of this problem was, let's see, 1/3. Okay, so if I come back down here, the amplitude here is 1/3. So that means the next point, I'm just going to estimate that 1/3 is right there, and I'm just going to mark it. Even though this might not look accurate, this is 1/3, according to my graph. And then finally, I just follow the pattern of sine. And then again, 5 pi over 4, I'm going to have to go down to -1/3. So let's just say -1/3 is there. And then finally here. And so I'm going to make this a dotted line. Now I just want to make something very clear, and I'm going to write it out in just a second so you can see it. But this graph, I'm going to call this the green graph, is the graph of y equals 1/3 sine of 2x minus pi. Now just think about that for a second. So if you think about what we have here, this is almost our answer, except for now we need to take care of the vertical shift. So I just need to add, I put or, I meant to put our vertical shift, which is +3. And that means that every single one of these points, and now I'm going to highlight them, I guess let me go with a darker green here, but every single one of these points that I'm coloring in, that you see being colored in right now, has to be moved up by 3. So we're going to start off with this first point right here. Now this first point's at 0. So 0 plus 3 is going to shift this thing up 3 units right here. So let me go and mark that new point here. Okay, so there's that point. The next point, this one right here, is going to be shifted up again 3 units, but it's at 1/3, right? So this one is at 1/3. So 3 plus 1/3 is just 3 1/3. So that's going to shift this graph up a little bit up here, just a tad bit higher than 3. And then we keep doing this. This point right here again is at 0. So I got to move it up 3 units, and that's going to put me up around right here where 3 is at. So let me just go to mark this spot. And then this point, the same thing. Now this point's at -1/3. So -1/3 plus 3 is 2 2/3. Now you can turn these into decimals if you want, but let's just say 2 2/3 is right here. So again, maybe turning them into decimals might make it a little bit easier for you to see exactly where these points are going, but 1/3 is not too bad. And 0 plus 3 again is going to put us right back up here. I'm going to go and connect this with a blue. I'm going to make a blue graph here. So again, this is what our final graph would look like. Something like this, right? Excuse my messy drawing here. Let me actually fix that. It should look something like that. Not that that's any better. But anyway, there's our graph. Now, if you look at our final answer choices, you're going to notice that we have nothing that looks like that. But think about this graph here. This graph technically goes on and on forever. So this graph can, if I extend it, it's going to keep making this same pattern over and over and over and over and over and over. And if I go in the other direction, again, let's look at this direction here, because this is more important. If I look at this direction, and my next point's going to be somewhere down here maybe, right? If I just keep following this graph the same way, it's going to go something like that. So if I mark this point, I'm going to do it in red so it stands out a little bit. But my next point might be somewhere around here. And then my next point after that, if I extend it, it's going to have to come back up to maybe about here. So something like that. And again, notice that this graph's going to keep doing that same pattern over and over. Now, if you look